Welcome. My name is Joel Ardman. I'm the Director of Business Development here at Carroll Engineering and one of the Vice Presidents. And I'm just going to give a brief overview of the company. And then we have a few different engineers on the call as well, and they're going to introduce themselves and talk a little bit about their department and projects and things of that nature. So, just a big picture of the company. If you haven't had a chance to look at our website, Carroll Engineering's been around since 1973, so 52 years old, so well established. We have 5 offices, 4 in Pennsylvania and 1 in New Jersey. Our headquarters are here in Warrenton, Bucks County. And we also have an office in Malvern, Chester County, Easton, Northampton County, and King of Prussia in Montgomery County. And our New Jersey office is in Hillsborough, which is central New Jersey. And we're about a 90-person civil engineering firm. So we do all the types of civil engineering that you can think of. We do water, wastewater, we do traffic engineering, we do structural engineering, we do planning and site design work, we do some environmental work, we do surveying, we have a GIS department, we also do construction inspection. So any projects that we design for our clients, we'll go out there and do the inspection. Just also, if you haven't looked at our website on our homepage, maybe after the event or when you have a few minutes, we have 2 pretty good videos. One is of the company that sort of gives again an overview of the company and our services and things of that nature. Then the second video is a culture video. It has some interviews with some of our engineers and the culture that we have in this company. Both videos are well worth taking a peek at. So with that said, I'm going to basically hand it off to Mike McCary, who will start. And Mike is the assistant department manager in our water wastewater group. So that said, Mike, take it away.
Okay, thanks, Joel. I assume everybody can see the blue screen.
Yes.
So, like Joel said, my name is Michael McCary. I'm a professional engineer, vice president, and assistant manager of the Water and Wastewater Services Department. I'm also a Drexel alum, who graduated in 2007 with an environmental engineering degree. My email is here at the bottom. This will be on the last slide as well. My email is mmccarry@carrollengineering.com. Feel free to shoot me an email if you want to ask any questions about what I'm going to talk about, submit a resume, or anything in between. I'll give a little overview of the water and sewer type work that we do. We are full service in terms of water and sewer services. So everything from taking it out of the river to your house and back again. So from taking it out of the river to a water treatment plant, everything within the water treatment plant, sedimentation, filtration, disinfection services. We do all the water treatment stuff. And then boosting it into the distribution system, pump stations, water storage tanks, and then all of the water piping within a street that goes to an airport, a factory, or a residential home. In other words, when you turn on the water in your shower and it comes out your faucet, we are responsible for getting it from the river to your faucet. And likewise, once it goes down the drain, we do everything on the sewer side of things. All the sewer in the street, pump stations and conveyance mains that get it to a wastewater treatment plant, and then all of the wastewater treatment plant things. Clarification, biological nutrient removal, disinfection, filtration, etc. We'll talk very quickly about the types of engineering work we do. Like Joel mentioned, we are complete turnkey work. So everything from a conceptual design, where we do a feasibility study to tell our client how they should upgrade their treatment plant or their pump station or their sewer. We'll survey the property in order to then develop AutoCAD drawings, technical specifications that actually specify the type of equipment that we recommend for the project, permit applications, things that need to get submitted to DEP, for example, design calculations, all the sizing of pumps and sewer capacity, all the hydraulics and fluid flow classes you would have had in a civil and environmental engineering program. Contract bidding, helping the client choose a contractor to actually do the work. And then the construction administration services. Everything that we do here at the office, RFIs and answering questions in real time, shop drawing reviews to actually prove to ourselves the contractor's buying and constructing the equipment that we specified, payment applications, as-built drawings, those kind of things, and field inspection. We pride ourselves in trying to have some of our younger staff then go on site and see the project get built. So I'll give a couple quick examples of the types of projects that we've done. This is a project I'm wrapping up now. It's a water storage tank in the Poconos in the mountains of Pennsylvania. It was constructed just last year in 2014, 72 feet high. It's this new tank here on the right-hand side. The one of the obstacles of this project was an existing tank right next to it that we had to build. It was 1.7 million gallons of potable storage water with the new tank, and it had an overflow elevation of 1380. By comparison, if you're on Drexel's campus today, you're at an elevation of like 100 feet. So it just gives you an idea. The tank was very much in the mountains. This is a shot from inside the tank. I actually got into the tank here in the lower left-hand corner. You can see the little personnel door there that I had to crawl through. Because the tank's sort of remote, we'd actually build the formwork and the concrete panels on site. Preferably, we would have did all the concrete work at a factory and had it shipped to the site, but we didn't have access. So what we did was, you can see that the tank is just a series of long rectangular panels here. And we actually built plywood formwork and then drove a concrete tank truck to the site, poured the concrete, let it cured, and when it was done and hard, stood up all the panels. You can see the little gray material in between. We basically put a metal plate to bridge the gap between the two panels and then filled it in with concrete. So a very neat project that we're just about finished with. Moving on, sewer pump stations. I took these pictures as well. This is also in the Poconos. It's actually adjacent to a golf course. You would never know it if you didn't know exactly where to look. On the left here is a wet well, the circular concrete chamber. So all the raw sewage, pools in this chamber with pumps. And on the right-hand side are the valve vaults and the instrumentation, your flow meters, your isolation valves, things like that, before it pumps into the system. There's another example of the type of work that we do. My last picture is a water booster station. We built this a few years ago. On the right-hand side here, you can see we worked with the other departments. We built the building itself, so we worked with our structural department. These gray panels here on the wall here, we worked with our electrical consultant to do all the power and communications for the booster station. And then on the left-hand side, I did all the calcs for the pumps and the piping. I believe these were 100 horsepower pumps, did about 3 million gallons a day of flow. So that was just a very quick overview of what we do in the Water and Wastewater Services Department. Again, my email is here at the bottom if you want to contact me directly. I'll stop there and turn it over to Justin, and we'll have some time again for questions if anybody has any, but we'll let Justin run through his little spiel next.
Mike, I did see there was one question I saw someone had. Do you want to respond to that now, or you want to wait till the end?
Stop sharing. Are you the ability to just read the question, Justin?
In the chat, how thick are the foundation walls?
The foundation was 2.5 feet of 2A stone and then 18 inches of concrete poured on top of it.
Wow.
And then the wall panels themselves were 8 inches thick, and they were reinforced with steel bars or rebar. Last thing I'll say about that project, it was also a post-tension project. So the walls were 8 inches thick, and then when we were done, we wrapped dozens and dozens of metal wire around the outside of the tank, and then install what they call shotcrete, or just a flowable concrete to spray over it to get that nice clean finish. So yes, it's a good question. It was a very interesting project overall.
I had a follow-up question.
Sure, go ahead.
Was the design itself within the scope of water engineering, or was it structural, which includes the design of the strength of concrete and bar reinforcement?
The storage tank was sized using hydraulic modeling. So I developed the water modeling software to identify where we wanted the storage and how much. So we had a rough idea how much volume we wanted. From there, sort of the raw was our oyster. And because of the remoteness of the site, the post-tension tank was chosen to be the most cost-effective option. It's basically a ground tank. It sits on the ground and then just extends up into the sky, compared to things like a hydropillar tank, which you've probably seen before, which kind of looks like a golf tee, a very skinny, long pipe in the middle, and then a big ball on top. So there's lots of different kinds of storage tanks out there, and everyone sort of has their own use based on the application. So this just sort of what worked best for us on this project.
Sounds good. Thank you, Mike. Beta, you want to pull up our slides for the structures? Thank you. So it's always interesting to hear how other departments, are doing in the projects they're involved in, because we always seem to be focused on our individual departments. So that's great to hear other projects going on, the type of work that's going on. So yes, Justin Coyle, Structures Department Manager here for Carroll Engineering. Worked primarily in the Warrington office in Bucks County, and now I lead the Easton office here in Northampton County. So kind of doing a little bit of work in both offices, but primarily working in the structures department. And I'll kind of go through the types of projects that we do. You know, as with any discipline in civil engineering, it could be broken down as far as, you know, your specialty. Those types of projects that I've been involved in personally, we do primarily bridge projects, bridges, culverts, retaining walls, not so much on the tall buildings or facilities type of work, but primarily for bridge work. So with that, yeah, class of 94 from Penn State, where I received my bachelor's and then later received my PE. We do require that all department managers in the company have their professional engineering license. So going to Drexel, doing your externships and whatnot, getting your EIT, and then is always a step to getting your PE. So with that, the next slide, as far as structure department work, I mentioned we do a lot of bridge work. We're involved from pretty much beginning to end for concept design through construction, inspection, and closeout of the project. So we'll do preliminary design, which typically is called a type, size, and location, and I'll show you an example in a minute what a typical drawing looks like. We are heavy involved in CAD layout, CAD design. We use a lot of bridge design software. All of our drawings are done in CAD, Civil 3D. But then the nice thing about the bridge work is it's not strictly a structural type of project. You're involved with environmental, you're involved with geotechnical, utility engineering, traffic engineering, highway engineering. There's a lot of different facets involved with the project. So that's nice. You get to work with other players on the team. You get to interface with agencies. So it's not just putting together structural plans. So I mentioned we use AutoCAD drawings. We're heavily into AutoCAD for preparing our plans. That's pretty much what we deal with as far as the end result is plans and specifications for the projects to be put out to bid, typically for counties, state agencies, and townships. Those types of owners that own bridge projects. And most of those items are public. We do plans, we do specifications, we do estimates, which is quantity takeoffs. So it's pretty much you get to know the projects intimately from the beginning to the end as far as putting your bid packages together. And then as the project proceeds through construction, we do bidding assistance. We'll have guys go out and do construction inspection to ensure the work is done in compliance with the plans. Construction administration, that's kind of acting as an agent for the owner. You're certifying payment applications, you're resolving issues in the field, making change orders in the field, processing change orders, doing shop drawing review. The contractor will make submissions during construction. You'll be reviewing those types of shop drawing submissions, whether it be for beams, guide rail, reinforcement bars, materials to be provided on the project. It's really an all-encompassing review. And then we'll review pay apps and close out of the project. Here's a typical, what we call the TSNL, a type, size, and location. So this is, like I mentioned, all done in Civil 3D. It lays out basically your general plan. This is a bridge project we're working on right now. I thought we'd be good to show when it's current. In Chester County, this is a replacement of an existing two-span bridge that we'll be installing a single span. So if you look towards the left side there, the existing elevation shows you the existing pier. So we're responsible for putting these drawings together. Initially, the surveyors will go out and do the base mapping or the contours, all the existing features, and then we overlay or design the new structure on top of those existing features. And then the bottom of that section there, the proposed elevation shows what the new bridge will look like in elevation. Next slide. This is a typical profile. So this bridge is over a stream. So we have environmental engineering involved. We have H&H, which is hydrology and hydraulics engineering, which will do typically a model in HEC-RAS, where you're modeling the stream flow using the FEMA flood flows, looking at the existing condition compared to the proposed condition, and then not proposing any increase in the 100-year flood elevation. So there's hydraulics and hydrology involved very early on in a bridge design, especially when it comes to overstream work. And then we'll lay out, that's part of our roadway design. You'll put the curvatures in. You're looking at things like stopping site distance, roadway curvature. Those things are all taken into account when you lay out the new road. So there's a typical profile of a new roadway. Thank you. Next slide. This lays out the typical section. The upper portion shows the existing section of the bridge. It's a steel beam bridge, and we're replacing it with pre-stressed concrete box beams. Our design would be the design of the beams, the design of the deck, the design of the guide rail. That all goes into the bridge plans. But this kind of gives you a flavor of the type of things that we do for bridge projects as far as the preliminary design. Next slide. Thought we'd give you a couple real world examples. Here's an example of a box culvert bridge we designed. This was Oakbourne Road, Westtown Township. This was a little challenging. It was adjacent to a railroad, so we had to install sheet pile along the stream to stay within the limits of the footprint of the bridge and not impact the active railroad. We had active utility lines, we had water, we had gas, sanitary sewer, all being relocated. So even though it was a relatively small project, it had a lot of moving parts and a lot of different coordination on our end. So with that, next slide. Another example of a culvert project we designed. This is basically a 3-sided frame, also known as a conspan. Shows you there on the right side the footings that are designed, the walls, the spandrel walls that are also designed for impact. This kind of gives you a nice picture of it. There's a size and type of crane that's utilized to set these type of precast pieces. Next slide. I believe this is our last bridge photo for design. This was a 3-span pre-stressed adjacent box beam bridge over a stream. This was rather long. This took about a year and a half to 2 years to construct. This was right before COVID that this was done back in 2018, 2019. So this was about 220-foot long span bridge that we designed. So just another sample of a type of bridge project that we do. Next slide. Here's an example for our construction inspection team. We actually are utilizing drones in our construction inspection. This was utilized for the Whitpain Bridge. This shows you the crane, how they have the pit excavated, how it's dewatered. There's bypass pumping. So all of this goes into the design plans. And then when our team is out there inspecting, we monitor the construction and recommend payments as it goes through for payment processing. But this is basically we're showing you we utilize the drone to be used on-site construction inspection services. Next slide. Last pictures of an amphitheater project. Like I mentioned, we do primarily bridges and small facilities. This is an amphitheater that was just built in Freemansburg Borough, Northampton County. Rather interesting project to be involved in. Custom designed, steel framing, CMU walls. It was a rather great project to be involved in. It's actually still being constructed, the second phase. So look for that to be opened up in, I believe, next year in Freemansburg Borough, but was glad to be a part of this structural design and overall for the borough. I think that's it, Veda, as far as projects, correct? Yeah, so hard to condense all of what we do into a five-minute presentation, but we just wanted to kind of give you a flavor. Heavily involved in AutoCAD, design aspects, very critical in the beginning stages. And then once it moves into the construction phase, we're very hands-on. We're monitoring construction payments to the client. So you're really involved from beginning to end, and it's a very rewarding profession, if I must say. So with that, next slide. I think that's just my contact information. And like Mike had said, if there's follow-up questions afterwards, or you want to reach out and send us your resume, feel free to do so.
I think there's a question in the chat. Inspection.
How big is our inspection team? Joel, do you want to speak to that?
Well, we have a whole inspection department. We have a variety of inspectors in different offices. Based on the season, we have anywhere potentially from, 5 to 8 to 9 different inspectors all over PA and New Jersey. So and sometimes the department will have engineers do some inspection work themselves, but we do have a full construction department that handles not only inspection, but different things are involved with construction management and things of that nature.
Okay.
So in a nutshell, that's what we have on that for that question.
Thanks, Joel.
So I guess Peter's up next.
Okay.
Peter, you're on mute.
Can everyone see my presentation?
Yes.
Good afternoon. I'm Peter O'Halloran. I'm the Traffic and Transportation Department Manager here at Carroll Engineering. We are a pretty small group, but we have our own projects, but primarily my department, we service the other departments in their endeavors. All right, so just to briefly discuss the types of traffic engineering work. Broadly speaking, you can break it down into 2 types. We have design work and we have study work. For design, that would include traffic signal design, And then also traffic signal system design. That would be a series of traffic lights that are connected and operate, relative to each other. And then obviously we also do roadway design, the design of the physical roadway. In addition, we would design the parameters of the roadway, such as how many lanes should it be, what kind of curves should be on the road based on the appropriate speed limits, that type of thing. Then for studies, there's a bunch of them that we do, but you can see here I've listed traffic impact studies, parking studies, truck restriction studies, stop studies, PED studies, or municipal reviews. Traffic impact study, that's probably one of the more involved one. That is if you have a new development coming into a township, a lot of times the township and PennDOT will require the developer to create an analysis of the existing traffic conditions and then the projected traffic conditions if that development was built. And then you do a comparison and try and ascertain what are the direct impacts of this development. And then we look to design mitigation measures to try and offset the impacts of said development. I've also mentioned municipal reviews. Here at Carroll Engineering, we do a lot of municipal engineering. So a lot of our work is reviewing traffic impact studies and design plans that come in from land developers. We review on behalf of the township, make sure everything, basically to make sure that the design serves the township and citizens of the township well. Some examples of these studies. Well, first of all, here's a picture of what's inside a traffic signal controller. So this is the whole thing on the left. And then on the right-hand side, you can see zoomed in, that's the controller, I guess, of all the components in the cabinet. That's the brains of the operation. The equipment you're looking at on the left is relatively modern, but by no means is everything in there state-of-the-art. I would say the equipment in there is on average 5 to 10 years old. And while it's very good equipment, as you can imagine, equipment is getting smarter and smarter and more automatic as well. So that's there's a whole bunch of components here. If anyone has any interest, please feel free to reach out to me and I can discuss any of them individually. But there's quite a lot there, so I'm not going to get into the minutiae of it right now. This is a specific project we worked on. It's a design project in Freemansburg, near the amphitheater that Justin spoke about earlier. So this is the main street in Freemansburg. It's a small little borough that's, I guess, part of the Lehigh Valley area. If you can see on the screen here, the design plans, we're looking at putting in designated parking spaces. We're including protected parking bump outs. We're also including rectangular flashing beacons for pedestrian and bike crossings, as well as just resurfacing the road and making it suitable for the town's purposes. So that project is under construction. So I don't have a finished image to show you, but you can see what it looked like a few months ago, right during the project. Of the scope of this project, we basically redesigned the road from curb to curb. And another project that we're working on currently, this is up in Lower Nazareth in the Lehigh Valley. The intersection you're looking at here is Buttstown and 191. As you can see, their angle of intersection is pretty acute, which if you are coming on the leg coming from the bottom, trying to make a left, it can be tricky between not being able to see where you want to turn or see the oncoming traffic. So the township asked us to redesign that to a more traditional intersection. So this is the project in progress. So here are our current design plans. As you can see, we've brought the intersection in at a perpendicular angle. And then we've the space that's left over, we've proposed to put in some nice landscaping. And we've also been able to squeeze in an initial left turn lane up here for folks who want to do that. Yes, that project is ongoing right now. So I know that's very brief, but that's my presentation. If anyone has any specific questions about anything, feel free to reach out to me. Thank you.
So why don't we go back to Justin? As you heard, we do quite a bit of municipal work. And Justin not only is a structural engineer, but also a municipal engineer. So maybe Justin can just touch on, our general municipal work that we do.
Thank you, Veda. Sure, thanks, Joel. Yeah, our colleague, Brady Flaherty, he's out sick today, so I'll kind of just briefly go over. He's our municipal department practice leader. He put together just a brief overview of what we do for municipal engineering. So this is, you got to think of, you're working pretty much for a municipality, for a township, for a borough, where they hire or appoint a civil engineer to do a lot of the civil engineering projects on their behalf, whether if you're reviewing plans for that municipality or actually doing capital projects for the municipality. So you're pretty much their right-hand person when it comes to civil engineering projects, whether review or design. And just listed here, municipal engineering gets to be a little bit more challenging. You have a lot more interface with the public, a lot more interface with clients because you're at public meetings. You're engaged more with the daily or weekly operations of that municipality, as opposed to working on, say, more of a design project where you're kind of working behind the scenes. Municipal engineers are definitely more at the forefront, involved with the public than other aspects of what we do for the company. There's ordinance reviews that have to be done, capital projects we mentioned. That could be for roadway work like Peter's group, curb and sidewalk improvements, like enhancement projects along a roadway. We mentioned that Freemansburg project. Paving maintenance, so that's doing either repaving, new paving methods, chip and seal, whether you're putting a slurry down. So that's more preservation and maintenance of roadways, which is very critical to municipalities because that's a lot of what their expenditures go to as far as roadway repairs and maintenance. Stormwater management is extremely critical nowadays, whether it's done with flooding or drainage controls. We're heavily involved in stormwater management projects, whether that's doing increasing pipe sizes, culvert replacements, upgrades, meeting water quality standards that DEP is imposing now on municipalities with the MS4 program. So it's really the stormwater is really blowing up at this time from DEP oversight as far as requirements that they're getting from DEP, and then just making improving the quality of life in areas that are prone to flooding and trying to come up with flood mitigation measures. And then, yes, parks and recreation, we can do any types of facilities. We're doing a softball field now, volleyball courts, pickleball is a big thing. So just getting involved, that's more on the grant side where municipalities are trying to improve their park systems, whether it's walking trails, pedestrian accommodations, any things you can think of at a park. And then construction observation, yes, we do a lot of construction observation on behalf of municipalities. Many of your smaller municipalities don't have that kind of staff to have people out in the field monitoring construction. They ask Carroll engineering inspectors to handle that for them. So we're involved in that level of oversight as well. So just a few brief things that are involved in municipal engineering for your information. And then I believe there's some slides that Brady provided for residential. We oversee residential construction. And then the next slide is a drone photo we took of a park enhancement that we did up in Upper Mount Bethel Townships, like I mentioned, for park work. And then Brady's contact information is there if you have questions for Brady, or you want to email him your resume if that's the kind of engineering you're thinking about doing and working for a municipality. So that's all I had. Thanks.
I think that's all the engineers and speakers are there. I would appreciate you coming on to the career fair, virtual career fair by Carroll Engineering. This was recorded, so we'll be sharing it. If you have any colleagues or friends or other students that may have interest that couldn't make this virtual career fair, then have them reach out to us. And appreciate your time. And if you have any other questions after we get off the line here, again, feel free to email any of the engineers that were listed on the in the presentation. Okay, thank you all.
Thank you, everyone.